Next ones. So source transformation. We learn about the Thevenin equivalent circuit and the Norton equivalent circuits. So those are all the equivalent each other, which means that they can replace each other. So we can replace voltage source in series with the resistance by Norton equivalent circuits. So they are same. So there is three components. They use a VT and R and the short circuits, so which means that I short circuits. And also here we can apply same thing, Ohm's law, IN times circuit resistance. There will be open circuit voltage, which means that that one is the Thevenin voltage. So same thing, those individual value I corresponding to the INs, VT is corresponding to open circuit voltage, so they can switch each other. One other example on here. So now here circuit was given one voltage source and the other one is the current source. So look at this. So here if we disconnect it on 2 points, then this circuit seems like a Thevenin equivalent circuit, and the other circuit from here to here, that is Norton circuit, and the other one is Thevenin circuit. They are combined together in this circuit. So either in this circuits we can replace the Thevenin circuit into Norton, and the right side, the Norton equivalent circuit, can be converted into the Thevenin. Either. Okay. Now one of the example on here. So left part, again this part is the Thevenin equivalent circuit, and right side Norton equivalent circuits. So right side convert into the Thevenin equivalent circuits like that. Okay, or this left part can be replaced with Norton equivalent circuit, right? So those are all the same. So now here we can calculate the current. So Norton equivalent current, which means that V over R, so 20 volts over 4, so 4 amp. So this 4 amp on here, and also here we can find out the Thevenin voltage VT, which means that IN times RT. So 1 amp and 10 ohms, so 10 volts. So that's a VT. So this VT plug in here. So this is one of the examples. So and next, from the Thevenin equivalent circuit, how can we transfer maximum power to the load? So here is the Thevenin equivalent circuit, and we want to transfer maximum power to the load. If this load connected to the open terminal, then we want to transfer maximum signal to the load. That's the questions. So now here the Thevenin equivalent circuits, and how can you deliver the maximum power? So power can be calculated by production of current and voltage. This times according to Ohm's law, we can convert into the other form, I squared times RL. So at the on the load we can calculate the power at R. So here current is that we can current calculated by Ohm's law. So V voltage VT over RT plus RL. So we can plug it in into here. So power Vt square and RT plus RL square and then RL. So now it's the RL equation. Those are all fixed value, so we don't know about the RL. RL is kind of unknown variable. So in order to find out the maximum power, so we need to differentiate it. So which means that dp over drl should be 0. So that when this value is 0, then this p will be maximum value, bring the maximum value. So we can differentiate it, then that value will be like RT plus RL force, and according to textbooks, so Vt square RT plus RL square minus 2 Vt square RL and RT plus RL equal 0. When this value is equal, then P will get the maximum value. So this term will be 0. So now based on that, we can calculate RT equal RL, then this value will be 0. So in order to deliver the maximum power, RL should be equal to the Thevenin resistance. So which means that RL equal to RT, those are same value on that, then we can deliver the maximum power on the load. So that's one of the conclusion on here.